Alright, multiplying fractions is about as easy as you get as far as fractions are concerned. Well, okay, that's not entirely true. I'd say reducing fractions is definitely easier, especially because multiplying usually involves reducing. In any case, if we're multiplying fractions, the rule here is to say that we can take whatever's on the top part of these fractions and multiply those together. That will give us the top part of the result. Whatever's on the bottom parts, multiply those together, and that will give us the denominator of the result. Now, this is, you'll notice here that 10 over 21, this is actually in lowest terms. We would actually be done there. However, oftentimes it's to our advantage. You can see if we did that same thing here, we would end up with 96 over 21 times 16. That's a big number. 21 times 16. You can't see what I'm doing here. That's 336. Equals 96 over 336. And at this point, I would, I don't even want to try to find the prime factorization of 336. It's a fairly large number, and it would take a little while. You'll notice that there's going to be a lot of cancellation here. There's going to be 2's. I'll be able to cancel out 2's a few times, and I don't know, maybe something else. Let's figure out if there's maybe a smarter way I could have gone about this. Instead of writing 96 up top, how about if I keep it as 32 times 3 and 21 times 16? Well, one of the nice things about doing it this way, if I don't actually multiply them together, I just kind of, don't find out what they are, I have smaller numbers that I can deal with. And I can see, well, okay, I have a factor of 3 up top, and I have a factor of 3 on the bottom. So, because this is 3 times 7, so I could actually cancel out a factor of 3, leaving behind a 1 up here, because 3 divided by 3 is 1, leaving a 7 down there. But that's not all. 16 is actually a factor of 32. 16 times 2 is equal to 32, so I could do some cancellation there as well. Let me write this out to try to reduce how cluttered it is. Well, when I cancel a factor of 16, it gets rid of this, I leave a 1 behind, and I cancel out this one, it leaves a 2 behind, because 2 times 16 was equal to 32. And you can see relatively quickly, I can get to 2 7s as my answer, and that I could actually have done it a little bit faster if I'd kind of made it a little more messy, but I'm trying to make myself understood here. So we end up with 2 7s for this number. A quick trick, a quick tip rather, to see if you're trying to check to see if you've made mistakes, what you can do is you can actually tell the calculator to convert both of these things to decimals. So if I do 32 divided by 21 times 3 divided by 16. I'm doing it in parentheses like this because I know that both of these divisions need to happen before that multiplication, and I'm just trying to make sure that everything happens as expected. So this gives me some decimal here. It's 0.2857, whatever. If I take my final answer and I plug it into the calculator, you can see I get that same decimal, 0.2857. And so this actually gives me quite a bit of confidence that this 2 7s is the correct answer. All right, let's talk about mixed numbers because you occasionally see them. I said to avoid mixed numbers. What I mean by that is don't give your answers as mixed numbers if you can help it. Unless you're specifically told to give your answer as a mixed number, just don't convert to them because there's no reason to. If you want to take something like 2 1/3 times 1/2, really the only reasonable way to do this is to convert this mixed number to a fraction. And if you don't remember, the quick way to do that is take 2 times 3 and add it to the 1. So 2 times 3 is 6, add that to the 1, we get 7. This is 7/3 times 1/2. At this point, it's 7 times 1 over 3 times 2. There's no cancellation that's going to be able to take place. So 7 over 6 is going to be my final answer in lowest terms here.